In today's lecture, we are going to create a low pass filter that is going to pass all the frequencies below cutoff frequency and going to reject all the frequencies that are above cutoff frequency. So for that, we are going to open MATLAB, and once MATLAB is open, we have to open simulink. We can open simulink by typing simulink in command window, and now we have simulink library browser in front of us. So now if you want to create an LPF, that is passive low pass filter, we need three elements. First of all, power supply, second resistance, and third is capacitance. So first of all, we are going to create that model, and for that we need toolbox named as sim power systems. It's available independently, but now we have it in simscape. So here we have simscape and we have sim power systems under it. So in sim power system, first of all we need power supply. In simscape, sim power systems, then sources, electrical sources, voltage source, then we need components like resistance and capacitance. So where we have resistance in elements, we have series RLC branch. We don't have any R, L or C independently, but we can convert any series RLC branch into R or L or C. So we need resistance here, and the value of resistance we can change here. We need a capacitor also. Again we have series RLC branch and we convert it into capacitors. So here our circuit is complete. We have power source, we have resistance and capacitance. Now we need to set the voltage. Suppose we are taking 5 volt with frequency 50 Hz. Actually this frequency we are going to vary, but now our task is to measure the voltage across this power source and this capacitor, because the output is going to be taken from capacitor, across capacitor. When we are going to discuss it, we know that the value of cutoff frequency, that is FC, is equals to 1 by RC. So we know that FC equals to 1 divided by 2 pi RC. Where C is value of capacitance, R is value of resistance, and if we have values of C and R, we will get the value of cutoff frequency. So comes to be 159.1549, that is 159.15 Hertz. So let's check it. Now if we are running it, we have been shown that initialization command cannot be evaluated because we have not included any solver, and we need a solver. So for a solver, we are going to library, and in sim power systems we have power GUI. This is the solver which is going to solve this whole circuit. Now our circuit is successfully run. Now we want two things: voltage across this power source and voltage across this capacitor. So our now we have multimeter also. So the voltage across any block can be measured by multimeter by just double clicking and opening this mask, and in measurement select voltage. Same we are going to do here, branch voltage. So we have applied measurement voltage in here and here. Let's see what happens. We have selected measurement voltage here, that is use source, AC voltage source. So first of all it comes here and we have AC voltage source here, and now double clicking second, voltage across series RLC branch 1, that is this one. We can rename it also. We can name it capacitor. Okay, so it is here. By double clicking it comes here. These are selected measurements. Close it, and now we have one output that represents both AC voltage source voltage and voltage across capacitor also. So we need two different measurements. First of all, we have to split. We have placed a demarks. Now we need to see the voltages. So display and one more display. We have two things. First of all, AC voltage source voltage and voltage across capacitor. So now if we run it, the voltage across this power source is showing some, because we need some AC power signal is varying with time. So DC equivalent of any AC signal is RMS. So we need RMS value. So we'll go to the control and measurement, then measurement, and we'll have RMS here. So we need to take RMS of the signal and then show it. Same thing we are going to do it here. So now if we run it, getting the values. Now you can see that the peak amplitude is 5 volt and it is showing 3.65. That is the RMS value of electrical source of 5 volt is 3.675. Now RMS value of input is this one. So for 50 Hertz frequency, output is 3.6 and input is 3.675. Let's increase the frequency. Let's make it 100 Hertz. It has reduced to 3.059. Let's change the frequency to, we know that cutoff frequency is 159 Hertz. So let's increase this value to 140. Again we are going to increase the frequency 160. frequency is reducing. And as we know, there is difference between ideal filter and practical filter. That's why this frequency is not reduced abruptly. This is reducing with a slant. So next we are going to change it to 200, and we'll do it until we are getting value almost 0 or near to 0. So let's increase it by to 500. Value is reducing. It's almost half. Then 1500. Yes,